right, so this is our second optimization video. In here, we are kind of reading through the question, looking at the diagram, and identifying that we are going to be finding maximum volume. Previously, we did maximum area. So now, if we're doing maximum volume, we are looking at volume of this rectangular prism, or this box, would be length times width times height. And in order to make a box, we're taking a piece of cardboard and we're cutting the same length out, or same little square out of each side, which is a length of h. So that means we're taking 2h away from each of those sides. That's going to be my new length and width of this box. So we want to have only two variables in here. We're going to substitute in 14 minus 2h in for the length, and 10 minus 2h in for the width. And then if you don't want to have to use product rule, I would recommend multiplying this out. So we would get 140 minus 28h minus 20h plus 4h squared. And then if you distribute the h in while simultaneously combining these two, we would get 140h minus 48h squared and then when we're maximizing, we're looking at first derivative, setting it equal to 0, because one of those values might be a maximum, one might be a minimum. So we can do, so setting up the equation is sometimes the hardest part of these. And then the second part is our calculus part. We'll do the derivative. So we'll do either v prime or dv over dh will be 140 minus 96h plus 12h squared. Now it is quadratic. I'm going to rewrite it in descending order. And in addition, if you want to make it easier to see if there is factoring capability, which there unfortunately is not, you may need quadratic formula for these, you can take out a 4 and be left with 3h squared minus 24h plus 35. Even though we do that, we are going to need the formula, so it'll be negative 24 plus or minus the square root of negative 24 squared minus 4 times 3 times 35 over 2 times 3. And you can put that in the calculator all in one shot. So I'm going to do alpha y equals. I'm going to just switch this to a positive 24. It's just easier. So I made some edits on this, so that was a little quicker to type in. I get one answer of 6.08. And I get a second answer, which I can go back and edit this one that I've already put in. I'm just going to go in and change that middle into a minus. And get 1.92. Now we could do our testing out and checking points on either side. If I did do that, just to give you an idea, kind of what we just did with our first and second derivative test. This will be the first derivative test. And I checked in between, I would get a positive here if I checked out and put, and you can do this pretty quickly. Again, if I plug in 0, this would come out positive. If I plug in 1, it comes out negative. And if I plug in like 7, it would come out to be positive. So the one that would be the maximum would be this one. But if you don't do the checking and you go to plug it in, if you plugged in this, it would give you a negative answer. So that would also kind of indicate that that wouldn't be the one that would work. So you may want to test them out just in the original equation and see which one comes out higher. Obviously, that's going to be a little more work. I'm going to plug it back into here. 14 minus 2 times 1.92. 10 minus 2 times 1.92. And then times the 1.92. So I'll actually just show you what would happen. I can plug that in using the store feature. If we currently store this one that we just did in x, and then type in that original equation. So do 14 minus 2x times 10 minus 2x times x. That gives me that maximum volume of approximately 120 point, was it 16? Okay. So this would be the height. This would be the maximum volume. And that's all it was asking. It said to determine the height and the maximum volume. If we did try to do the other answer, which was the 6.08, I'm just going to go up and grab it and store that in x instead, just to show you. And then I go back and grab this original equation to plug it into. Notice that comes out negative, which doesn't make sense for volume. So if you didn't do your checking with your number line, you could check by plugging it in and take the answer, the two answers that would match up with the maximum. So the 1.92 inches would give you the maximum volume, and the 120.16 inches, I actually wrote squared. Since we're doing volume, this should be cubed because we have 3 dimensions. So all right, so that takes you through one of our box examples. We are going to do one more maximum area example in a last video.